guys, this is the second part on finding the derivatives of exponential functions. And basically, obviously, there is a first part, and I will link it down below in the description box. And I'm going to just cover more complicated and more sophisticated examples, if you will. As a quick recap, in the first part, I went through kind of basic types, basic kinds, when you are given something like e raised to the 5x power 3x, or it could be more complicated, more sophisticated power. The way you would handle these types of problems is applying using the chain rule. And I might sound like a broken record because I'm going to repeat myself like 100 times or even more. So the chain rule basically asserts, the chain rule says, all you do is just take the derivative of outside function, leaving the inside function alone as is untouched, times gets multiplied by the derivative of inside function. And by the way, I do have a bunch of videos on the chain rule, how to use it, when to use it, the basic types, algebraic functions, and all this jazz. I will link all these videos down below in the description box. And if you need this extra help and more examples to study, definitely go ahead and check them out. Now today I'm going through all of these functions, all of these equations. And for the first one, you are given two chunks being subtracted. The way you would handle this, you want to take the derivative of the first one, and you need to take the derivative of the second chunk. So one by one, and you want to string them together for a full derivative. And since you are given square root of something, you have to apply the chain rule to the first one. And to be honest with you, you have to apply the chain rule for the second chunk, since you are given 2 over function, and your function again, it's not just e to the x, it's e to the 2 of x, but I will get into this in a while. For the second one, you have 2 pieces divided by a number, so at this point you cannot take the derivative straight away, right off the bat. You want to divide through, you want to use some algebra and break it down with algebra. So you will just divide by 2 and get 2 separate chunks, 2 separate chunks. And after you will take the derivative one by one piece at a time. And finally, for the last one, you have 7 and you have brackets. The way you will deal with this, you handle this, again, apply your basic algebra skills. You want to expand this expression, distribute this 7 over both terms, and after, again, you end up getting 2 chunks. And you need to take the derivative of each chunk individually one by one, and after you string them for the full derivative. So let's get into this one by one. Let's have a look at the first one. So you have y equals 5 times square root of e to the x minus 2 over e to the 2 to the x. So you are given 2 chunks, you are given 2 terms, 2 functions, and the way you would find the derivative, you want to take the derivative of each piece one by one at a go. And after you want to string it for the full entire derivative. So let's have a look at the first piece, at the first chunk. You are given 5 times square root of e to the x. The derivative y prime equals, first of all, you want to keep this constant, which is 5. Now, you are given square root of something, and obviously you are given a composite function. Your function is made of a square root, which is going to be your outside function, and you have something inside of the square root. You are given e to the x. E to the x is your inner function, inside of the square root. And again, your best friend, the chain rule, comes in. So, and again, I might sound like a broken record because I'm repeating it 1 million times at this point. So all it says, you want to take the derivative of outside function, which is square root. And the derivative of a square root of something is 1 over 2 square root of this something. So go ahead and write it down. So 1 over 2 root of something. This something happens to be e to the x. And again, the derivative of square root of x is 1 over 2 square root of x. You could remember this derivative as a separate rule, as many people do, and I do belong to this number of people because it comes out a lot when you do calculus. But if you don't want to remember, or if you don't remember, or if you don't have to do this, so you could every time derive it from the standard old-fashioned power rule by rewriting a square root as a half power, applying the power rule at this point. And after, since you end up getting something like a negative a half, you want to bring it down in the denominator by making your power positive and rewriting your a half power as a square root. Anyhow, you end up getting something like this. And since we are not done yet, since again it's a composite function, so it's a function of a function. So this one gets multiplied by the derivative of inside function. So we have to take care of the derivative of inside function that happens to be e to the x. And recall that the derivative of e to the x is just e to the x, so it gets multiplied by e to the x. And we are done with the first chunk. Moving on to the second one. Minus, subtract off, you want to keep it. You want to keep this 2. It's a coefficient in front of your fraction or in front of your function, if it makes sense. And the way you would handle the derivative of the second one, you want to rewrite it as a e raised to the negative 2x. Recall that old-fashioned exponent rule. So when you have your power down in the denominator and when you bring it up, so you want to make it negative. And at this point, you have to take care of the derivative of this one. So I'm going to clean up a little bit the first chunk since we're done with this one. So I'm going to place 5 and e to the x on top. So it becomes, your derivative becomes 5 e to the x over 2 root of e to the x, that's from the first term, minus, you want to keep this 2, and again, at this point, you have to apply the chain rule. So the derivative of outside function remains the same, and your outside function is e to the power, so it's e to the negative 2x, and this gets multiplied by the derivative of inside function. So at this point we have to take care of the derivative inside function, which happens to be negative 2x, and the derivative of negative 2x, it's going to be just negative 2x goes away, x disappeared, and you're left with something like this. And we are done. We are done with derivative, but we don't want to leave the house like this. Just clean it up, use your basic algebra skills to simplify it as much as you can. And look at the first term. It needs a little bit simplification since you have e to the x and root of e to the x. It's the same thing as a e to the x raised to a half power. And when you divide the same base, you want to keep first of all this coefficient in front, and you want to subtract this power, so basically x minus a half of x. Again, since square root of x, it's the same thing as a e to the x raised to a half power, and the half gets multiplied by x, so you end up getting just a half x. And since you have division, and when you have the same base, the common base, you want to keep moving on to the next term. Since you have negative 2 gets multiplied by this term, so negative negative overall becomes positive, so it becomes plus 2 times 2 gives you 4. And at this point, I'm going to bring this e to the negative 2x down in the denominator by making your power positive. It becomes e to the positive 2x. And finally, the last step. So you're left with 5 over 2. X minus a half of x, you end up getting 1 over 2x, and again you want to rewrite it as a root, so it's the same thing as a square root of e to the x, plus the second chunk 4 over e to the 2x. And that's gonna be your final derivative for this function. Oh, I'm tired. Say you have this one. So the idea is you want to use your basic algebra skills. Break it down, break it up with some algebra. You want to divide through by these 2 in order to separate the numerators. So it becomes 5 over 2 e to the 2x power. And I'm going to write this way in order to kind of bring it in front, this coefficient 5 over 2, in order to this function e to the power kind of stands out, pops out at you. You want to add plus, and since this second term gets divided by 2, so basically it's the same thing as a half, so this coefficient we can kind of pull out, if you will, in front, e to the negative 2x. And at this point we can take the derivative, we can differentiate this function with respect to x. And again, the way you would handle this, you want to take the derivative of the first chunk, and you have to take the derivative of the second one by one. So for the first one, basically, we already did this kind of examples. First of all, you want to keep this coefficient in front, which is 5 over 2. And again, first of all, identify your outer function, your bigger function that has something inside. So your outer function is going to be e. So the derivative of e is the same e. So it's going to be e to the 2x power. And we're not done yet. Since you have something inside your inner function is 2x. So this one gets multiplied by the derivative of 2x, which is just 2. You want to add plus. Let's move and deal with the second term. So first off, you want to keep this a half in front. And the same rule, the same chain rule applies precisely the same to the second chunk. So you want to keep e to the negative 2x in this case. And again, chain rule pops in. So gets multiplied by the derivative of negative 2x. And you are left with just negative 2. Clean it up as much as you can. Here's great news that these 2 and these 2 cancel each other out. Magically, beautifully goes away. The same applies for the second one. 2 and 2 goes away. And I'm going to pull this negative out front. It becomes 5 e to the 2x power, so 2 goes away, beautifully, magically disappeared, gone. You want to pull this negative in front, minus e to the negative 2x power. And technically we are done. You could leave your answer like this, but would you leave the answer like this, with negative power? You would probably do, but not for me, and I wouldn't sleep that night, and honestly I need a good sleep. Well, what I mean by this, that for some teachers, for some books, for some exams, it's okay to leave your answer with a negative power. Whatever question you do, whatever problem you solve, but personally for me, it's not okay. And I would go ahead and rewrite my term with a positive power, and I would have a good sleep. I need to have a good sleep. So it becomes, I'm going to rewrite the first term as this. There is nothing to do with the first one. So it's 5e to the 2x power minus, subtract off. And for the second one, you want to bring this negative power down in the denominator by making your power positive. So it becomes 1 over e to the 2x power. And that's gonna be your final derivative for that problem. And again, maybe I'm making too much fuss about this, and this is technically correct. That's fine. That's totally fine with negative power. But sometimes your book, your teacher, your exam states that you have to give your answers in positive powers. Anyway, either way you want to or you have to. Alright, the last one, and let's call it a day. 7 times brackets e raised to the x squared power minus 2x. The way you would deal with this, you want to multiply through, you want to expand. So bring this 7 over these terms inside of the parentheses. So remember, when you open the top, when you get rid of the parentheses, you take the 7 and you multiply by both terms inside the parentheses. So it becomes 7 times e to the x squared power minus, you want to keep subtraction sign, 7 times 2, you are left with 14x. And again, life becomes much more easier. You are given 2 chunks, and the way you would find the derivative, you want to take the derivative of the first chunk minus, subtract off the derivative of the second chunk. So look at the first chunk. Again, it's e to the power, and chain rule kicks in. So you want, first of all, you want to keep this coefficient 7 in front. So your outside function is e. The derivative of e, it's the same, e to this power. Again, your function is made of x squared, which appears to be an inner function, and you want to take the derivative of x squared, and the derivative of x squared is just 2x. So this term gets multiplied by 2x, which again comes from the derivative of inside x squared. And moving to the next term, for the second term, the derivative of 14x is just negative 14, so x goes away. And finally, the last step, clean it up. So you want to combine, so these two numbers need to be multiplied together. 7 times 2, they would leave us with 14. You want to bring it in front as a coefficient. X goes also in front before e to the x squared power minus 14. And technically we are done. This is your final derivative. Since your both terms contain that 14, so 14 appears in both terms, you can factor it out front as a last step if you will, but again you could leave your answer like this. That's totally fine, but just for the sake of fun, x e to the x squared minus 1. That's gonna be your derivative, your derived function, or the gradient function, if it makes sense, so if you will, for that one. Now let's have a look at the first one. As I mentioned before, you are given 2 chunks. You are given 2 terms, 2 functions, if you will. And the way you would find the derivative, you want to take the derivative of the first chunk, namely 5 times e to the square root of x, subtract take away minus the derivative of the second one. So let's start off with the first one. So you're given 5 times e to the square root of x. Let's call the entire function y for the sake of simplicity, and y prime, the derivative of dy dx, whatever suits you best, whatever you prefer you like, you could use for the derivative. So for the first chunk, you want to first of all keep this coefficient 5 as is, so you don't want to change it. And now you are given a composite function. You are given e to the square root of x. So basically in the first part, this function pop up at you, and as a quick reminder, so all you do is just take the derivative of outside function, which is e, and recall that the derivative of e to the x, e to the u, is just remains the same function, e to the square root of x. And we are not done yet. So at this point, at this moment, you have to use the chain rule. So you need to take the derivative of inside function, which is square root of x. So your function consists of the square root of x. And recall that the derivative of square root of x is just 1 over 2 square root of x. And again, you could memorize this as a separate result, or you could derive this fact, this derivative, from the standard power rule, rewriting your square root as a half power and applying the power rule, the old-fashioned power rule at this point. And after, you want to bring your x down on the bottom and change your negative half into positive half, and after rewriting your half power as a root, if it makes sense. We're done with the derivative of the first chunk and moving on to the second piece, the second chunk. You want to subtract, and this one basically, you could rewrite it as a 2e to the negative 2x. It's precisely the same, since recall that power rule properties, and since you are given power or exponent down in the denominator, and if you want to bring it up to the top, you want to change, you want to make your power negative. So at this point, we can apply the chain rule. We can find the derivative of this e to the negative 2x. And I'm going to rewrite the first piece as is. The way I would like to just clean up, just place this 5 times e to the square root of x on top of this fraction. So it becomes 5e square root of x over 2 square root of x. You want to keep this subtraction, so you want to keep this coefficient in front, times. And again, at this point, chain rule comes in. So the derivative of e is going to be just e to the negative 2x. And again, at this point, we have to apply the chain rule. So we have to take care of the derivative of negative 2x. And the derivative of negative 2x, they would leave us with just negative 2. Since the derivative of x is just 1, x goes away, basically x disappears. And all you need to do is just again clean it up. We don't want to leave the house like this. And the way you would do, I'm going to just rewrite the first chunk as is because it's done. So 5e to the power of root over 2 square root of x minus. So basically, you want to pull this negative in front, and negative becomes positive, and you want to get this e back in the denominator by making this power positive. So 2 gets multiplied by 2 and you are left with 4. I'm going to place it on top over e raised to the power 2x. And that's gonna be your final derivative for this function. Alright guys, I hope it has been helpful to you. Huge thanks for watching and train your brain. I know everyone hates math, but if you like my video, please hit this like, share with your friends, leave the comments down below, and make sure to smash that subscribe button and turn on this notification bell so you will not miss out my new uploads. Oh.